This is a quick video series to talk about how we can build a simple card memory game using Java and JavaFX. So the idea of the memory game is that we have playing cards, and if you flip them, well, they happen to be a match. If I flip them over and they're not a match, then it counts as a guess. And if I keep guessing until I get a match, then I have a count of how many are correct. So you've probably played similar games at one point in your life, and if you want to keep playing, I can say play again, right? And you can just keep going on and seeing if you can improve your odds from 50%, which is what I'm getting. So that's what we're going to build out today. So to do that, we're going to need a few different things. We're going to need to create the idea of a card class so that our game has the idea of a playing card. A playing card knows its suit, knows its value. It can represent itself as an image, and we're going to need to also create a deck of cards so that we can get all kinds of different cards where we can shuffle them and get different combinations each time we go through the game. And we're also going to need to explore how JavaFX works. So we're going to design a view that allows us to dynamically add more cards if we want to make, instead of this one has 10 cards, maybe we want to make it with 12 cards or 14 cards. So we want to create a system so that this game can be made harder if we want to. So that's all part of the design phase. So let's jump right into it. So let me just close this down. And I'm going to use IntelliJ. And we're going to select a new project. When the new project window comes up, make sure you select JavaFX. And in here, I am going to just call this, I don't need the marking section here. We're going to call this the memory game. So I'm using Java. I'm going to use the Maven build system. And everything else here is pretty standard. I'm going to use JDK, 17, the Oracle standard. That's the long-term support at the time of creating this video. And I'm not going to worry about any of these extra tools. And what this does is IntelliJ will build you kind of hello world for the GUIs, for a little application. So if I hit play, we'll get a little GUI to pop up that says hello. And if you click the button, it says welcome to JavaFX application. And if you're familiar with the model view controller architecture, that's what they use by default. So if you expand the source directory, you can see under resources, there's a view. And that's just a fxml file. I don't usually look at fxml files in their raw. I typically will look at them in a nice utility like Scene Builder, where it'll show you visually, what the objects are. And the other thing you'll see up here is a controller. So we talk about models, views, and controllers. The controller file is used to tell you what should happen when the user interacts with the view. It controls the view. And the other part of this is the model. So we talk about a model. That is, we're trying to represent something from the physical world around us inside of the computer. So we would model it inside the computer. That's where the name comes from. So if you've ever, when you were younger, maybe you made like model airplanes. They look just like a big airplane, but they're small and plastic. It's the same idea here. We're going to take a playing card and try to represent it inside of the computer. So when you want to design a model class, the tools that we use for that are something called a UML, that stands for Unified Modeling Language, class diagram. And it's a very simple diagram to look at. Let's start with the idea of the card class. So at the very top, you have a card object. And inside of the card object, you have a couple things that you need to represent, which would be the suit and the face name. So if we look at it, this is, the King of Hearts. And on here, I can tell the suit, which is hearts, and the face name, which would be king. And if I know those two things, I can derive everything else I need to know about the card. For example, I can get the card to represent itself as a string, so king of hearts as a string. I could get the color, which would return the color red if I had spades or clubs, right? Cards like this. Then it would return the color black. And the card value can be determined from the face name, right? So a 2 is worth 2, a 3 is worth 3, and that just goes all the way up until we get to Jack, Queen, King. And then we just, I think it goes 10, and then Jack, so Jack would be 11, Queen would be 12, etc. So that's the idea of a regular playing card, okay? Now, when you get a deck of cards, typically they come in a box and you get 52 cards. So we should also have some kind of class to represent that. So a deck of cards contains, I've made an array list, so some kind of collection that can hold card objects. And the types of things that a deck of cards can do, you can shuffle a deck of cards, you can deal the top card, and you can do things like get the number of cards. And then down here at the bottom, we have this idea of a memory card. Well, that's where it gets a little bit unique. It's pretty easy to picture, the 2 of diamonds as a card object. But a memory card, when we place these all down on a table, the table itself, if we see a match, we can maybe take those cards away. We have some unique way when we play the game with physical cards to recognize the card is matched. In a computer, that's not so easy, or it's not as easy. So we're going to create this special class called memory card. So a memory card is a regular card, but it also has this ability to track whether or not it has been matched. And it will have the ability to compare itself to another card. So let's start building out these model classes in this video. So the model classes are always built in Java. So we're going to go, if we look here, our project's broken down into Java files and resource files. So we're going to go into the Java file here. I'm going to right click on this directory and say new Java class, and I'll make a card class. And if we go to our class diagram, you can see we have 2 private instance variables. These little minus signs indicate that they're private. That's the UML standard. So you've got your variable names, and your data type is after the little colon there. So we're going to say private string suit, private string face name. And you may wonder why we use a string here for the face name, because if it's 2, 3, 4, why not just use an integer? But when we get to Jack, Queen, King, and Ace, we want to be able to represent it properly. So we're going to need it as a string. If I do Alt Insert, or if you right click, you can go to Generate, which also tells you you can hit Alt Insert, and click on Constructor. Now we can create the constructor. So as I'm building this video, I'm running with the assumption you understand a little bit about how Java works, or how object-oriented programming languages work. Whenever you create a class, you should have a constructor. So if you create an instance of your class, this is the method you would use to do that. And in here, we should add some form of validation. So for example, the suit should only be hearts, clubs, diamonds, or spades. And similarly, the face name should only be 2, 3, 4, all the way up to Jack, Queen, King, Ace. So what we do for that validation is we'll say set suit. And here I'll say set face name. And again, if I do Alt Insert on a Windows machine, I think it's Option. Actually, I'm not sure on a Mac. On a Mac, I would say do your Command click and look at whatever it says down here. But whoops, do Alt Insert. I'm going to hit the getters and setters now. And this will create all of my get and set methods. So these variables up here are private, which means we can only access them within the class. But we have these public methods, which means we can call them from outside of our class to get the values of these private instance variables, or we can set them. So if we look at the suit as an example, we talked about, what are the valid options. So if we do some Javadoc here, we say valid suits are hearts, diamonds, clubs, and what's the last one there? Spades. Okay. So if this argument that's passed in is one of these words, then I want to set the instance variable so that my object has a valid suit name. So what I'm going to do is I'll create a little method that returns a list of type string called getValidSuits. And I'll just pass these items into this list. So now I can access that list both within my class and anywhere else in my program. So I can say if getValidSuits contains the suit, we'll set the instance variable. Otherwise, we'll throw an illegal argument exception, and we'll say suit must be, we'll say suit invalid. So what this does is we'll validate that suit, right? Whatever we pass in here is one of these 4 strings. And if it's not, we throw this illegal argument exception. We'll actually stop our program from running because we have an invalid state. We don't want it to run if we have an invalid state. It's better to actually catch that, fix the issue, and then keep going. So let's test this out. I'm just going to create a temporary experiment class. So in here, if I say card, ace of spades equals new card, and you can see here, IntelliJ prompts us. It says, hey, this is where the suit gets passed in. I didn't type suit. That's just part of the development environment. It makes it a lot easier versus trying to memorize what goes into each of these spots. So I'll say hearts, or I guess I said spades in this one, so I'll say spades. And the base name is an ace. So if I run my validation, I'll just print this thing out for now, the ace of spades. This creates an object. It doesn't have a very nice description, but it does create an object. It's a card object. You can see that here. And if we wanted to display a little bit nicer, what that is doing is it's actually calling the object class. So all objects, all things in Java are objects. So these are sort of showing you how things are, how they're nested. So for example, in this example, an image view is a type of node, and a node is an object. A label, you can read through all that, but eventually it is an object. So when you have a parent class like this, you inherit all of the methods in the parent class. So the object class, way up here in the top, which is common to all classes in Java, has a method called toString. And what it does is it basically gives you your directory structure and your class name, and then it gives you this hashed value that it means something to the computer system. But if I run it again, I might get a different number here. It doesn't really mean much. So if I want to change that in my card class, I can go in here and I can say public string toString. And IntelliJ is very smart. You see this little O here? It's recognizing that I'm overriding a method, and you can see in the object class. So whatever I do here overrides that. So if I say return bananas, whenever a card goes to represent itself as a string, it'll return the string bananas. But that's not really useful to us. It'd be much better if we returned the face name plus the word of, and then the suit. So if we run it again, now it returns the ace of spades. Now we can do a lot of protective coding as we go along. So for example, what happens if someone writes it like this, the ace of spades, but they put an uppercase letter in there? Right now, what happens is it will break. It'll say spades is invalid, must be one of hearts, diamonds, clubs, or spades. And you have to have a keen eye to notice uppercase versus lowercase. So one workaround for that is in our card class, where we're setting the suit, we can say suit, so what was passed in equals suit to lowercase. So now it'll convert whatever was passed into lowercase to do the comparison, since these are all in lowercase. And that just makes it a little easier for other people to use our code. So now it works. All right, so let's do the same thing here with our face name. So just to speed up the video a little bit for you there, I just typed this bit out on pause. So it's the same idea as before. We're going to make a list of what our valid names are, and I'll put that in a little method. So get valid face names. Oops. Need to add in here list string. And I'll just put all of these in there. So now you can see, because we have that in a nice method, it makes our code in set face name quite simple. We can say if valid face names contains our argument, set the instance variable, otherwise okay, and I'll do the same thing here where I'll make it all lowercase. So I'll say face name. So in Java, in most programming languages, what happens here is this equals is not, it's not trying to ask the question, are these two things equivalent? A lot of times what you'll see people call this is the assignment operator. So whatever is on the right-hand side is assigned into the left. So we take whatever the face name was, and we convert it to be lowercase, and then we reassign it back to that same variable spot. Okay, so now our card class is got the ability to validate its face name and its suit. And if we experiment a little bit here, we could try another card. Let's say King of Hearts. And if you want to duplicate this line, you can do Control D. Oh, I've got kind of hearts. Let's do King of Hearts. There we go. And got too many brackets in here for some reason. There we go. So if we run this, we should see on one line the ace of spades and then the king of hearts. So it's validating, it's working, things are good. So let's go back to our design for a second here. So our suit and face name are there, our constructor's there, we've got get and set methods, our toString works. Now we've got this method get color, which we actually don't need for our game, but it's a good experiment to build the logic into that so you can get used to programming. So if we do public string get color, that's the Canadian spelling of color. If you're watching this from the United States, and you're like, what's with the U? That's crazy. Canucks do it that way. So get color. So if our suit equals hearts, or suit, actually I don't need to extract it, suit equals, the other one we have would be diamonds, and we'll return the color red, else we'll return black. So it's good little logic, and it gives me an opportunity to talk about comparing strings. So it's very important when you're comparing strings that you actually use the method dot equals or equals ignore case to compare strings. It's I see a lot of people make this common mistake where they'll say if suit equals hearts, and the problem with using this operator here, equals, is it's actually comparing if they're the exact same object, not necessarily comparing that they're the same, they're a string with the same content, right? Because it's quite possible that they're two different objects, but they both say hearts, as an example. So let's take a quick look at that. So if I go back to my little experiment over here, if I were to say string suit equals new string hearts, and I were to say string other suit hearts, if I were to say suit equals other suit, right? So they're two strings. They both have the content of the word hearts. It'll compare if they're the exact same object. And because I've said equals new string here, they're not. Whenever you call the new, it's going to call the constructor and create a new object in system memory. So if I run this now, it's going to return false. But if I were to do it with the suit equals other suit, right? This will just compare if they have the same characters inside, and that will be true. Okay, so it's just an important little subtlety with how to compare objects. All right, and the last one here is the card value, which again we don't really need for our comparison game, but it's still good to discuss a strategy for this. So if we look at our card class here, we can see that the value of these, I'm going to actually copy this. Let's go down here and we'll say public. Okay, so we need to figure out a strategy on how we can convert a string into a number. Now, for the first several items here, it's easy. There's actually a method in the integer class called integer.parseInt that will take a string, see if there's an integer in it, and return an integer. But that won't work well for these items. And we could put like a switch or a conditional thing that checks, if it's a jack, return 11. But again, that's a ton of work. So it's always good whenever you can see a pattern to use it. So in this case, we already have a method that will return all these numbers or all these face names as a list. So if I look at this as a list, if I were to, put square brackets around it all to say it's in a list, this would be the first position, right? So in computers, you start your counting at index position 0. See if we can get that to line up a little bit better. And then the next position is 1, 2, 3, 4. Hopefully you see the pattern here, all the way to position 12. 12, 13. I'll have to actually. So, how do we convert a 0 to be a 2? Well, basically, we're going to add 2 to it, right? So if I take whatever the index position is in this collection and I add 2 to it, I'll get the value. So let's give this a try. So I'll say get valid face names. And then there's a method called index of, and I can pass in the face name, right? So now it'll tell me what index position that particular card is. And then I can say +2. So this evaluates to be a number, and I just add 2 to it. Let's give it a try. We go to our experiment here. Clean this up a bit. So we have 2 cards. We have the king and the ace. Let's do a simple card as well. Let's do the 2 of hearts. Whoops. Okay, so if I say the value here, so let's So what this will do is it'll go to the ace of spades object, and it'll print out ace of spades, right? So this %s is a placeholder for a string, and then %d is a placeholder for an integer. I don't love that they called it %d. What the d stands for is a decimal number, right? So in computers you have binary, like base 2. This is base 10, is what the decimal or %d represents. So we'll get the card's value. And then I'll do Control D, and I'll just change this to be the king of hearts and the 2 of hearts. And if you're wondering how do I type it that fast, I hit T in this case, and the computer's going to suggest 2 of hearts. So I just hit Tab, and we'll hit Run. And so now we can see that 2 has a value of 2, king's 13, and ace of spades is 14. Which tells me I was off by 1 here. So, there we go. So now our card class is complete. And that's going to be the end of this video. In the next video, we'll look at how do we make a deck of cards and add in some of the other features such as shuffling and dealing in that class.